Question 6, we see a triathlete cycles 20 kilometers on a south or southeast bearing to the finish line. How far to the nearest kilometer has the triathlete traveled in a southerly direction? And so we got to draw a diagram first for this. So um, this south and southeast bearing part is drawn like this. We have to firstly start by knowing where south and east is. Southeast is this way, and south or southeast means we have to start at southeast, but go more towards the southerly direction. So that means we're going this way. That's south or southeast. And so we are traveling at 20 kilometers. All right. So if we're traveling 20 kilometers, that means this is 20. And what I'm going to do also is I'm going to label this angle here as 22.5 degrees because we know that's half of the 45 from south to southeast. So now that we've got that, I'm going to erase these things here. And it wants you to find out how far has this triathlete traveled in that solid direction. So it's going this way. All right. So we've got the angle right there. We've got X, which is the adjacent edge, as well as 20 being the hypotenuse. So now we've got cosine of 22.5 degrees equals to x over 20, which means 20 cosine of 22.5 degrees equals x. So 20 cos 22.5 will be roughly around 18 kilometers to the nearest kilometer. Okay. Now for question B, what is the compass bearing of the starting point from the finish line? So we've got the starting point over here, and they cycled to this point. So we're now starting from the end, okay, which is the finish line over here, and we want the compass bearing to the start. So how we're going to do that is this. We need to know an angle to turn that's closest to north because that blue line is closest to north. So that angle here, if I just zoom in a little bit, that angle here is also 22.5 degrees because it's alternate to this angle here. So let's have a look back at our knowledge of compass bearings. If we want this particular angle here, okay, which has an angle of 22.5 degrees, that's actually the direction between northeast and north. So that compass bearing there is north of northeast because we start from northeast, but it's closer again to north, so we chuck an N in front of it, and that's what this is. So it's north of northeast, and that's our compass bearing for this question. Right, let's go to the next one. Question 7, a hiking group, oops, I repeated that word. A hiking group walks from Sine Flats to Black Ridge, a distance of 20.9 kilometers in the direction 78 degrees. They then turn and hike due south to River's End and due west back to Sine Flats. How far have they hiked together? So there are 3 places. There is Sine Flats, there are Sine Flats, and then Black Ridge, followed by River's End. So the first direction they travel at is 78 degrees. That's somewhere towards the top right. Then they have to go south, which means they go down, and west back to Sine Flats. It looks like kind of like that. Right, which means we'll start from the bottom left, so we have enough space to draw. We're now going to draw our first walk from Sine Flats, so I'll call that S for Sine Flats, to Black Ridge, which is over here. And that's a distance of 20.9 20.9 kilometers, according to this. We are now going to go down to river's end, okay, and it has to stop at this point. And the reason why is because they are now going west back to Sandy Flats. So it has to be directly across each other, like that. Okay, so how far have they hiked altogether? Well, firstly, we have to know what angle inside the triangle is. So this angle here is 90 minus 98, since those two add up to 78. Sorry, 90, which means that this will be 12 degrees. What we're now going to do is find BR and SR and then add the total of all these lengths together. So we're going to use sine ratio first to relate opposite and the hypotenuse. So we'll go sine of 12 is equal to BR over 20.9. Now if you multiply it over, 20.9 sine 12 is equal to BR. Now we don't have to really care what that is because that's not our final answer. So we'll leave it. Then we've also got our adjacent edge here and our hypotenuse edge here that we have to relate to each other. So we're going to use cosine of 12, and that's now equal to the adjacent edge here over the hypotenuse. So that's SR over 20.9. And again, we're going to multiply 20.9 over. So 20.9 cosine 12 is SR. And therefore, we have these two distances. So SR is this. And we've also got BR, which is this. Okay. So now we're going to write down the total distance. So our total distance is equal to 20.9 plus BR, which is 20.9 sine 12 plus 20.9 cosine of 12. So what we're going to get from that, okay, let me just type in our calculator, is roughly to 0.1 kilometer will be 45.7 kilometers. Okay? Right, question 8. A plane takes off from Darwin at 10:15 a.m. and flies on a bearing of 150 degrees at 700 kilometers per hour. How far due south of Darwin is the plane at 1:45 p.m.? Okay. So we're going to do this first. So if a plane takes off at a bearing of 150 degrees, that means it's going somewhere towards the southeasterly direction. So it's going to be going this way, also at 700 kilometers per hour. Okay, so we firstly have to know, since that we have the speed there, that's going to be used to calculate our distance that we traveled from there to there. So distance equals to speed times time. Our speed currently is 700 kilometers per hour. The amount of time that is spanning from 10:15 a.m. to 1:45 p.m. is 3.5 hours, or 3 hours and 30 minutes. So we're going to multiply that by 3.5. 700 times 3.5 is going to be 2,450 kilometers. So we're going to write that right here. Okay. So in a right angle triangle, we're trying to locate and find out how far south Darwin is the plane at 1:45 p.m. So Darwin's there, and we're looking for how far the plane is, which is here, south of Darwin. Okay, so we're going to look for that edge. We'll call that X. We need an angle inside the triangle, which is this one, and that's 180 minus 150, which is 30. got these two edges, which are adjacent and hypotenuse. So we're going to use cosine 30 is equal to x over 2450. So if you multiply that over, then 2450 cosine 30 is equal to x. So that means x is roughly around 2,122 kilometers to the nearest kilometer. Now for question B, what is the bearing correct to the nearest degree of down from the plane? So from the plane means start here and find the bearing starting from north in a clockwise direction towards Darwin. So we're trying to find that. This bearing is comprised of 3 quadrants worth of angles, which is 270 degrees, plus an angle here, which we'll call theta. Okay, so let's try to find out what theta is. That theta will just be simply 180 minus this angle here. So we'll get 180 minus 30 minus 90, which is simply 60 degrees. And so the full bearing will now be 270 plus the theta there, which is 60. So we'll go bearing, okay, is equal to 270 degrees plus 60 degrees, which is 330 degrees. Okay, that's how we do it. Right. Question 9. 2 racing pigeons are set free at the same time. The first bird flies on a course of 40 degrees, whilst the second bird flies on a course of 130 degrees. The first bird flies 200 kilometers until it's due north of the second bird. Find the distance apart, correct the decimal places. All right. So you've got 2 pigeons that start from the same point. One of them is going in this direction, okay, 40 degrees from north in a clockwise direction. The other one, however, is going to go on the course of 130 degrees. That's about 40 more than 90, so it's somewhere there. Okay. Now the first bird travels 200 kilometers until it's due north of the second bird. So it's going to look like this. Okay, so that's 200 kilometers. And now what happens is that first bird is now directly above the second bird. Okay, so we've got first and second bird there. Now we've got to find the distance apart. All right, well, let me just complete that second bearing that we just got there, which is 130. So if this is 130 degrees, then this remaining angle inside has to be 90. Okay, so we get that by getting 130 subtracted by 40. This makes a right angle triangle here. Now we're trying to find out the distance apart. So we're trying to find out the hypotenuse opposite the right angle. Okay, so we'll just call that x. So we've got another angle here that we can find out just by using alternate angles. Okay, because we know that the first bird is directly on top of or north of the second bird. That means this direction is north, that direction is north, so that means they're parallel to each other. So this is also 40 degrees, which means that we've got 200 as our adjacent side and x as our hypotenuse. So we'll use the cosine ratio. So cosine 40 is equal to 200 over x. And since x is on the bottom, we're going to swap these two around. Therefore, x equals 200 over cosine 40. So 200 over cosine of 40 will be equal to roughly around 261.08 kilometers. Right. The next thing we're going to be asked to do is find how far the second bird has flown. So that's asking for this distance here, which is y. So again, we'll use this angle. We've got this edge being the opposite edge, and then this edge here being the adjacent edge. So we've got opposite adjacent, which means we have to use tan ratio. So tan of 40 is y over 200, meaning that our next step is to multiply 200 over. So 200 tan 40 is y. So 200 tan 40 will equal to roughly, to two decimal places, 167.82 kilometers. Okay, and that's how you do question 9. Right, question 10. Okay, so for question 10, it says here, Mel went in a stand-up paddleboard race. She paddled from point 1 in a bearing of 135 degrees for 4.2 kilometers, then turned at point 2 on a bearing of 45 degrees, then continued for 2.8 kilometers to the finish line at point 3. So the first part that she traveled, okay, according to this sentence, is going to be labeled here. So that's the first angle, which is 135 degrees that they traveled at for 4.2 kilometers. Then she turned at point 2, and that's at an angle of 45 degrees. So I'm going to call this 45 degrees and continued for 2.8 kilometers, okay, to the finish line at number 3. So what is a true bearing from the finish line, okay, to the start? So that means we have to join up the start to the finish, okay? And what they want us to find is the bearing from number 3 to number 1. So starting from north in a clockwise direction, we've got to find that angle there, okay? So how do I find that? Well, I know that the completion of this angle requires us to get this angle as 45 degrees. Okay, so I got that by getting 180 minus 135. Now, if I use alternate angles, then this angle here is also 45 degrees. And if I add that with the other bearing already, okay, that gets you 90. So I'm going to create a 90-degree angle there. So the other thing I could do is if I want the bearing here, I can find this angle in green. So we'll call that theta. I can also add that up with 45 because this 45 is also here. Okay, so you've got the green part, this black part, which is 45, and you've got this remaining part, which is 180. So let's try to find the green part. That green angle there can be simply found by relating the opposite edge, 4.2, as well as the adjacent edge, 2.8. So we're going to write down tan of theta equal to 4.2 over 2.8. So theta would equal to inverse tan of 4.2 over 2.8. So we're not interested in exactly what that is, but we'll leave it as it is for now. However, our bearing is going to be equal to the sum of 180 degrees plus by this black angle, which is 45, and that theta that we just found out. So we're going to write 180 plus 45 plus by the inverse tan of 4.2 over 2.8. that will get us okay, this will get us around, to nearest degree, around 281 degrees. Okay, which sounds right, because that looks like a reflex angle. Okay, question 11. All right, I might just do 2 of these, and then you can do the rest. Consider the following points O, A, B, C, D, and E on the Cartesian plane. Round the answers to one decimal place. Find the bearing of A from O. So what this means is start from O, okay, O is here, and if I just point north, and I have to go in a clockwise direction and angle it so that it's now going to reach towards A, okay, what angle is that line there? Okay, that will be 45, because if you think about it, okay, well, it's going up by 2 and also right by 2, okay, which means this line is actually directly between y and x, okay, so that would just be 45 degrees, okay. Now, if I go and find D from O, okay, from O there to D, well, I need to find out this whole angle. Now, to find out that whole angle, I can simply create a triangle right here and find out what this angle is here. I'll call that theta. Now, this distance is 3. This distance is 2. So if you want to find what theta is, then that means I have to use tan theta that relates opposite and adjacent. So tan of theta would equal to 2 over 3. So that means theta is inverse tan of 2 over 3. Now once I find whatever that theta is, which is this, I get 3/4 worth of that angle minus by that theta. And that will be our bearing. So our bearing is equal to 270 minus inverse tan of 2 over 3. So 270 minus inverse tan of 2 over 3 will get us roughly to one decimal place. It is 236.3 degrees. Okay. I'll do one more actually. So for question 3, we've got B from C. So we start from C and we want to go to B. So I'm going to create a line that joins those two things up together. I'm also going to just try and create a right angle triangle like that. Okay. Then get some measurements. Okay. So if it's from C to B, you start with a cross at C. You point towards the north of C and think, how much do you have to turn this arrow clockwise until you reach B? So we want to find what this angle is here. This distance is 4 from 1 to -3. Okay. Over here, this distance is 2. So the value of theta, which is the bearing, is going to be found by relating opposite as well as the adjacent edge. So we're going to use tan of theta being 2 over 4, and theta will just be inverse tan of 2 and 4, which is the same thing as inverse tan of 0.5 anyway, and that will be roughly around 26.6 degrees. Okay, so you can use that to help you with the rest of these questions down here.